Bonjour, bienvenue dans le cycle de conférences Monstro. Aujourd'hui, on est super content et contente d'accueillir Sarah Nichols. Et je vais laisser Emmanuelle vous présenter cette conférence. Voilà, qui va se passer en anglais.
Thank you, Sarah, Nichols. Thank you, everyone, for being here. So we're going to introduce you in English because your lecture is going to be in English. I hope everyone understands. And if you have any question during the lecture, you can interrupt and ask to repeat, right? Your French is okay also. You can understand questions. So, Sarah, so you're an assistant professor at EPFL. Sorry, I took notes because okay, nothing is working today, so sorry about that. So you're an assistant professor at EPFL, and you're the director of a laboratory called TEMA, standing for Theory of Environment, Material and Architecture. And your work digs deep into the environmental and political aspect of construction, focusing particularly on materials. Today, you're going to talk about concrete. For us, and why for us, inviting you here is a chance to explore what we might and what you also call monstruosity of concrete. So not to label it simply as a monster or a marvel, but as a material that reveals also our own limits and shows us what it may or may not fit into a certain context. And also, as part of our heritage, we need to understand how to deal with concrete. So how to repair it, how to respect its fragility, and how to reframe its place in the broader story of our mineral resources. And in this sense, monsters refers to an architecture that steps outside of a traditional meaning, and also with the idea of prosthetic and repair, and an architecture that can be augmented and transformed with graft and an ongoing process of renewal. So we are very happy to have you today, and we are looking forward to your presentation. And if you want to add anything about what I just said, you're welcome. Otherwise, we're just listening to you.
Great, thank you, Emmanuelle and Jacques-Marie for the invitation. It's very nice to be here. As Emmanuelle already said, you are welcome. If I know it's very difficult to listen to a lecture in another language, and if you have any question, if you don't understand, feel free to interrupt. The most important is that you're able to follow. So I really enjoyed the brief of the lecture series and how it relates to the course. And I will talk to you today, not like this is a history course, but like this is a design studio, and to think through historical things with different ideas about design and materiality. And I really want to emphasize this idea that there is a very fine line between the monstrous and the marvelous, as you have it in the brief, that this is a reflexive relationship. But at the same time, that there is a multiplicity to monstrosity that can also teach us a way of looking and therefore a way of designing. So let's see if this works now. Yes. So I had a particular monster in mind when putting this lecture together. It's just one slide. I won't talk about it anymore than this, but maybe we can come back to it at the end. And that is the creature from Mary Shelley's Frankenstein, which I think we often forget the subtitle of, which is The Modern Prometheus, which gives a very different idea of the creature as something that holds a lot of promise than the interpretations that we know from popular culture. And so I put this up here because of the inscription, a quote from John Milton's Paradise Lost, that I think will resonate with what you'll see today. It says, "Did I request thee, maker, from my clay to mold me man? Did I solicit thee from darkness to promote me?" And if someone, when we return to this at the end, wants to ask me something completely unrelated to concrete, I can tell you why I think Frankenstein has been totally reinterpreted and misinterpreted and needs to be understood as a feminist novel. So let's now go to concrete. And I want to start this. This now is not working because I've changed the slide. Here we go. So there's a bit of a delay. So the first thing that I want to put on the table is the question of quantity in relation to concrete, which is one of the questions that I think occupies us the most today in the profession of architecture and should occupy us more in the broader field of building in general. So engineering and construction and the real estate economy are all equally culpable. And so what you see here is a graph that is made of all of the in-stock materials all over the world that are locked into buildings or infrastructure, not things that have been demolished or replaced, but the things that are in buildings, roads, bridges, dams, everything like that. And what you see here is that, and so this is all of the material intensity of humanity that is currently in use. And what you're able to see from this is that aside from the two smallest things, the pink and the blue at the bottom, which are iron and steel and wood, everything else is related to concrete. It's either the sand and gravel going into concrete, it's the cement, or it's the underworks that are done to support roads or other structures that we put on top of them. And so, as I put in the brief, I think this is the monstrosity that we understand of concrete today. This is the Leviathan, the fact that concrete is everywhere. But in order to understand how we got here, we have to understand also its promise. Something cannot be monstrous without also being desirable. And so here's a very simple drawing, but one that I like to show from the late 19th century. Before reinforced concrete was widely used, béton armé. And this is a demonstration that was supposed to be built at the Swiss National Exhibition, where the builders tried 3 times without any reinforcement, without any iron or steel in this, just out of mass concrete to build an unfinished arch. And each time the structure cracked, and they didn't understand why. And so what this shows is that before concrete was in common use, there was an idea, there was a belief that it exceeded its actual ability, that was eventually willed into being. And so to put this more explicitly, what that shows us is that materials aren't just made physically, they're not accidents that we end up with. There's no genius who discovers them. Materials are produced not just physically, but also conceptually. They become what we want them to be. So if concrete is a monster, it's because we made it that way. So concrete comes to be thought of as permanent, monolithic, or liquid, as a kind of entanglement of idea, technology, and material, where these things are co-producing and where we have a lot of agency. And so I put this here so that you understand this gaze in the image as a constructed view. In this case of people trying to show concrete as something that is scientific, as something that is under control. But think of what you know of concrete on a construction site, where it's messy, it's difficult, it's easy actually to use it by yourself without any sort of engineering expertise. It's used for a lot of people building their own houses worldwide. And so there is a desire to show and to create concrete in this way, in this image. And so concrete is a monster without form. So to guide us through the ways of it being monstrous, I'm going to use a building that gives it a figure. And that's a building called the Goetheanum in Dornach that was built in the 1920s as part of Rudolf Steiner's anthroposophic community there, which is it's a whole nother topic. It's a kind of esoteric, pseudo-religious community that borrowed a lot from Eastern philosophy, but also the writings of Goethe. If you know anything about the Waldorf or Steiner education, it's related to this. And this is a building it's one that was explicitly referred to as monstrous even before it's built. So this is a quote from a handworker's journal before it was even built, kind of criticizing this monstrous edifice being the work of a dilettante. And so it's a building that was completed out of completely monolithic, exposed, cast in place reinforced concrete, extremely unusual at the time. to house a performance hall mainly, and the adjacent offices around it, as you can see here. And as I already mentioned, designed and also conceptualized by Rudolf Steiner, the founder of this movement. And so this is actually replacing a previous building, the first Goetheanum, that was built in wood, as you see here, that burned on New Year's Eve on 1923 before it was finally completed. And so there's one other structure from this period that is remaining that looks like this, to give you an idea of what this original structure would have looked like. And it's in the aftermath of this fire that they decide to rebuild the structure out of concrete. And so I'm going to go through now a couple of the things that I already mentioned as aspects of why this building is in concrete, what makes it monstrous, as more general principles about concrete. And so the first is this idea of resistance. When the building before completion burned to the ground, the concrete base remained in place. And so this is sort of the origin story of why it's built. The second one is built out of concrete. But this was not an exception. It wasn't one thing for one building. There was an entry point for reinforced concrete because cast iron construction had spread rapidly at the end of the 19th century for warehouses, for high-rise buildings, for bridges. And as this happened, kind of unproven technology being used very, very broadly, there were also a lot of disasters. We didn't understand the properties of the material under certain loading conditions, but also when exposed to fire. And so this, for example, that's still the worst rail disaster in Europe, or in Switzerland, and one of the worst in Europe, which happened just outside of Basel at the end of the 19th century. A bridge constructed by Gustave Eiffel fell when two trains were crossing at the same time. And it is only after this moment that reinforced concrete begins to be taken seriously as an alternate material that was considered safer. So when François Hennebique introduced his system for monolithic reinforced concrete construction, he also launched a journal called Le Béton en Mai. And as you can see on the side, there is this repetition of the slogan that's on the cover of all of the editions of the journals over decades that says, "No more disastrous fires." And so it's this positioning of the material against something else, as something that is resistant to disaster, that allows concrete to have this opening in our building culture. But this was also part of a colonial mentality and part of the colonial apparatus. Concrete buildings couldn't be burned, so they were better at keeping occupied territory under control. As also then, so then the types of disasters that concrete was purportedly more resistant to kind of proliferate. So there are two then major earthquakes in Messina and San Francisco that become these disasters become evidence in an argument supporting concrete. And so images of disaster are printed and circulated worldwide in these professional journals to show, look, this is what happens when you don't use concrete. And so there is this operative use of a split screen view of kind of destruction on one side and preservation on the other side to make this argument in favor of concrete. And I'm trying to denaturalize this for you. I'm trying to show you how thin the evidence is, but at the same time, how the argument was constructed, why it seemed attractive at the time. And at the same time, of course, there were also many examples of concrete also failing. So here are kind of forensic documentation of a building collapsing in Basel in reinforced concrete just after the turn of the 20th century. And so they studied why did this collapse? But each time a reinforced concrete building collapsed, they didn't attribute it as to something inherent in the system itself. They attributed it to an exception. They said there was bad work or someone substituted the wrong ingredient. They used cheap gravel. And so this was kind of ignored and these arguments continued. And I would say they continue until today, and they're also still highly gendered. So we think of concrete as something that is unusually strong, and unusually male as well in its strength. So if resistance, this idea that concrete could kind of survive anything that was thrown at it, was the first sort of property that in the Goetheanum responds to the fire. The next is the idea that it is base. And so that base is, first of all, the base of the building, literally the foundations. And so again, after the fire, the first Goetheanum, this base was all that was remaining. And so you can see here as well in the, there's always a delay, in the construction photos that first building, the base is cast in place concrete and the upper part is wood. And so when they replaced this building, there is no longer a differentiation between the base and the upper structure. It's all done as well. So the foundation of the building is coming up out of the ground and becoming the rest of the building. Again, at the time, this was really unusual. There are almost no exposed concrete buildings at the time, with the exception of a few from Paris that were not cast in place like with this board-faced concrete that you see here. And so what this reminds us of is that primarily in the 19th century, concrete was a foundation material. So these are even later notes from a student at ETH in their architecture courses who are learning about concrete only in terms of how to use it for foundations. And we could extend this to infrastructure and other things, but it wasn't considered in the 19th century an architectural material. And so that's one of the reasons why this Goetheanum building was described as monstrous, because it was taking a material that should be underground and putting it above ground on display. And even though we don't think of it that way anymore, this relation still holds, even if we don't see it. And so this is a much later section through a hydropower plant with river turbines, where you see, if you look only at the upper structure, this is what's known of the building. It's a light steel structure, but there is all of this concrete below ground that you never see and you never think about that is making the building possible. And so this is one way that concrete was considered base. The other way that concrete was considered base was about the status of the material itself and what it was made out of. So 19th century concrete took sand and gravel that had been excavated from the construction site. It mixed it with water that was also often there, and then added a hydraulic binder, which was either lime or cement. And so because of that, because these materials were incredibly cheap, incredibly available, again, it wasn't considered very architectural because it was too cheap to be something that was treated with dignity. And so at this time, there's very little divide actually between the renaissance of interest in Pisé construction that begins at the end of the 19th century with Coirot, and later is kind of cemented also with Rondelet's description of it as well, and what we would understand as concrete construction in the 19th century. And so basically all of the early aspects are there: the need for formwork, the fact that you need to ram it into place, the use of the material on site. And these were things that were considered rural practices. They weren't considered part of the work of the architect or part of the work of monumental building. So this attitude can be summed up by the title of a lecture in 1871 that was given at the AA, titled "On the Architectural Treatment of Rubbish." But there were also minority voices that at the time were, sorry, there's a lag again. There we go. That were a little bit ignored, but in the history have been sort of focused on, that saw a different possibility in this. They said, well, actually the accessibility of this material is its promise. And so François Cornier coined the term béton économique and built this house outside of Saint-Denis in the mid-19th century with the idea that this was, again, that this the ease of labor and the low cost of the material was exactly what made it exciting for architecture, and that this combination could actually transform the way that we think of architecture itself. So he imagined actually that these cheap and disposable buildings would allow each generation to have dignified housing that they could change from one generation until the next. And this later becomes sort of weaponized and taken on as a socialist slogan, where when in Bern in the 1920s, a new Maison du Peuple was built for the Socialist Party of the city, right in the middle of the medieval city center. It was criticized by the public and by architectural critics, saying that it was built out of mud. And the architect turned it around and he said, yes, it's out of mud and iron, just like our workers. It takes things that are, it takes these things and it makes them even stronger because they are not exclusive and elite. And so we have resistance, we have base, and now we have poured or monolithic. And so we know today of concrete as something that is poured into place. And this is a photo of a construction site that happened around the same time as the Goetheanum, and you can see the workers standing on the reinforcement wearing raincoats and helmets waiting for the concrete to pour from above. But at the time, this is something that was extremely new. So we turned concrete into a material that was liquid because we wanted it to be liquid. We wanted it to flow. And that's how we get these images of the workers here sinking into the wet concrete. And we get also these myths, mostly, of workers falling into the concrete and basically being entombed in the liquid as well. And so, again, arising out of Pisé construction, concrete at the time was usually mixed with very little water. It was hard to work. You had to really beat it into place. This is where the word béton comes from. You were ramming it with a rod into the formwork. It took a lot of labor. But there were always ideas about this process being earlier. And so this is the time I'll mention Le Corbusier in the lecture, but Corbusier, but also Thomas Edison in the US were, for example, two voices that had this idea of how easy it would be if concrete would be poured. And that this vision of a flood kind of transforming natural resources into new materials, of houses of liquid concrete poured in a day, was that this fascination with the idea of pouring preceded the technical reality. It's based on the idea of construction as something that is quick and easy, but durable. And so there are notions here of economy, repetition, removal of skill, and removal of workers, a way to automate that would remove the discomfort of architecture's reliance on labor. And so again, this happened before it was a widespread procedure. But in the 1920s, around when the Goetheanum is being built, to reduce labor, but also reliance on skilled labor, particularly, this wet mix concrete, first developed in the US, was rapidly adopted in Europe on a large scale to take on bigger projects faster. And when this introduction happened, it was kind of botched because no one really understood what it meant to add a lot more water to the material. And what it did is that it made the material very brittle. And so there's a whole generation of projects that basically had to be rebuilt because the concrete was falling apart the moment it was finished. And I think this rush to use wet concrete, what it shows is that this idea of flow, of ease, was so powerful that it threatened to supersede the other qualities of concrete that had already made it a material that was competing with all of the other materials that we know, like masonry and wood and cast iron and so on, because they knew already that adding this water reduced strength and durability. And just to even back up further, there were, again, minority voices even early in the 19th century where we see these ideas being put forward, those such as the Swede C.G. Rieden, who suggested that concrete would be ideal work for women which in turn would save construction costs because you hardly needed to pay them. And so this is an early example of this de-skilling argument that later becomes crucial for the introduction of cast concrete. But pouring meant something else, and that something was very important for architecture. It will show up now, yeah. And that is also this idea that it can be monolithic. And so you see that again in this Le Corbusier quote, that the idea of a single pour, the idea that if you're pouring everything in place, that it can eventually become one solid block of stone, an artificial stone, but a stone nonetheless. And so this was also actually a problem, but an interesting problem for architecture, where so much of architectural theory was about tectonics and about how do you represent the joint between the different materials, about the flow of forces. And then suddenly you had something, first of all, an indeterminate system that was taking forces in both compression but also tension, but also something that was entirely solid. So you have very funny examples here where this is a difficult thing for an architect to put forward because it's poured in one go, but then they sent stonemasons in to chisel the entire facade and to rebuild classical elements, so individual pieces, out of what was a monolithic whole to kind of remove that instability. But there were other ways of understanding this monolithic notion. And so what you see on the other side is the idea that actually the thing that was super disturbing about reinforced concrete is the fact that there's this steel inside that you never see. And it's playing a huge role in the way that the structure is working. And so it destroys everything about the material truth that you can't see the way that it's actually working. And so what the architect here is trying to do with this proposal for a bridge is to use this fluting to show kind of conceptually this hidden reinforcement. I mean, these things maybe seem silly to us today because we don't think in the same terms, but at the time this was really a kind of crisis for the profession of how to treat this material that nobody particularly liked, but that they understood was sort of coming anyway. But then, you know, there were also other ways where possibility was seen. And that, again, similar to the Goetheanum, is with this idea that when you're pouring, you can make any form you possibly want. And of course, this is totally untrue because any form that you want to make, you have to build a formwork for. So sometimes when it's very complex, they would even bring in boat builders so that they could bend the wood panels in a particular way. But there were examples where this inspired a particular idea of an organic form that couldn't even actually be executed in concrete. So what you see here is what we have here is an example of a tower that is inspired by the idea of concrete. This idea that that Eric Mendelsohn had this idea that the organic form of concrete could produce a totally new architecture, but then actually what he tried to conceal is the fact that when they went to actually build the building, it wasn't possible to do it out of concrete. So the entire thing is done in brick masonry, covered by a very thick layer of plaster in order to make the organic curves. And the last thing about this liquidity is that it introduces uncertainty and a lot of also throwing of blame and discussion of labor conditions, because one of the things that's very unusual about concrete is that it's not just something that is delivered on site and sort of built up in a very obvious way where everyone can check the work. There's so many different variables. There's the quality of cement, there's the quality of the sand and aggregate, there's the quality even of the water. There's the quality of the way that the formwork is built, the way the concrete is mixed, how long it sits out, how it's put into the formwork. And then after all of that, at this time, you would have to leave the concrete to cure for weeks on site. And so you would wait and wait and wait, and eventually you would remove the formwork and just hope that what you find is that the concrete has been, is what you hope it will be. But of course, things went wrong all the time. So this again is another early collapse where the false work couldn't support the weight of the wet concrete, but also very commonly and increasingly, there's a delay. You would have pretty much on any construction site problems more like this, where you take a column out of the formwork and you have places where the concrete just hasn't reached, the rebar is exposed. And of course, in this case, it means that the structure will not be able to be maintained. But you also have then superficial problems, like when the drying is uneven, you get this kind of cracking pattern. And so increasingly, with the idea of the surface being exposed, this is always shown as the thing that is natural, as if it's like easier to do than covering it, because you're already pouring the concrete into the mold. So why would you cover it in plaster or anything else? You should just show it because it's there, right? But because these things were going wrong all the time, and because it's so difficult to control the surface of the material, this is actually the most difficult way of doing a concrete structure. And so over the course of a few decades, you get more and more control, not just over the material conditions, but over the conditions of labor, just to make sure that the surface of the concrete that the architects want to expose is as clean and smooth as possible. And so that wasn't a result, it was a highly curated process that really changes the way that the workers are acting on site. And this process is predicated also on hidden forms of care that show us that the material, that actually hide that the material is as vulnerable as it is and make us think that this is something that is easy to do. So this is a recent example from the National Museum in Switzerland in Zurich, designed by Christian Gantenbein. This is a terrazzo floor in one of the rooms. Where the concrete didn't settle properly. And so a few days before the opening of the exhibition, they shaved off the layer of the top cement, and they found that they weren't able to see any of the kind of artistic aggregate that was in it. And so I don't know if you can see it on the photo, but everything that you see here is painted on. None of this is actually aggregate. And so there is an entire industry called, in German, it's called Betonkosmetik, I don't, Kosmetik de Beton, that is about actually going in and when there are these surprises, when things come out of the formwork, correcting them so that which reinforces, which is hiding the vulnerability of the material and reinforcing this myth that it is solid, inert, that maintenance is not needed, just like actually are cosmetics. So now I'm going to turn away from things. So until now, what I've been talking about is characteristics that we can directly link to this one particular monstrous building, the Goetheanum. But from now, that was finished in 1928. And from now, very quickly, just for the end of this, I'm going to begin to move forward. And so to sort of speed up, we have, by this moment in 1928, when that building is finished, we have this idea of pouring, of ease, the idea that concrete can be used almost anywhere. And so we see this here at the scale of a building, but also at the scale of things that are so big, it would have been previously unthinkable to take these on in a span of years. A hydropower dam of this size used to be a generational project. With these new technologies for pouring concrete, it could be done in a couple of years. And so that meant that by the year that the Goetheanum was finished in 1928, the architectural historian Siegfried Giedion looked at what was going on in France and said, maybe prematurely, he looked at these gasoline tanks, sugar refineries, and reinforced concrete, but also iron and steel infrastructure, and claimed that these networks of extraction, storage, and distribution amounted to a redesign of the Earth's surface. And so this is where we start moving a little bit from a tipping point, an idea of a resource or a building material that is scarce, that has limits, that you have to use economically, to something that is potentially endless. And that brings us back, of course, to here. So what happened in the meantime, we reach in the post-war period, as we see in this graph, this possibility of ubiquity. And this is where also the position of architecture changes, because the building is not a solitary object anymore. It's one thing that is part of this bigger network that is being made out of the same material that is all interconnected. So your house is connected to the plumbing, which is connected to the roads and runways, to the hydropower being produced in the electrical network, to these underground spaces, and so on. And so how do we make this shift? How do we jump out of scarcity? So part of this is a little bit technical in the economic sense, but it has to do with the way that we understand a building material as a commodity. And in order to explain that, I'm going to talk about wheat, as William Cronin describes it in his book about Chicago, Nature's Metropolis. So, and there is this transformation, more or less, which happens, which allows concrete to be endless, which is that we move from an idea of something which is concrete or specific to something which is abstract. And so what that means is that cement was no longer one of the commodities that was a specific product of human labor on a particular tract of earth, but it was an abstract quantity that could flow anywhere. And the way that this is done is through the normalization of cement at the turn of the 20th century under national norms that determined its key qualities, which were mostly its compressive strength. And so once that's determined, it means that the market becomes either a monopoly, a cartel, or a state industry, because there's no way then of competing with a different palette of products. And so this is how we arrive through this abstraction, which allows us to use cement in ever greater amounts, to the industrial networks that we understand today. So the people who were setting these norms and standards were, as this critical graph from the World War II era shows, that in this case, Lafarge and its board members were deeply connected to the colonial apparatus. They were deeply connected to the major financing infrastructures and so on. And so you have these this dual build out, which is intimately related. On the one hand, that cement becomes something which is abstract, can be used anywhere, but also the people enacting that abstraction can do so because of these, can allow this to go anywhere because their network effectively goes anywhere. And so here I'm showing the way that this builds out as a global material, not as something which is always local and even and fair, but as something which is highly asymmetrical. So in this case, Holcim, which of course has merged in the meantime with Lafarge, a tiny Swiss company, but one which over the course of the 20th century spreads around the globe. And so we think of cement and concrete as something that is produced locally, but really it's a capital intensive industry that's globally dominated by a small handful of companies that increasingly merge and create even bigger corporations. And so that means while labor and material might be local, financing and management are centralized. And it also means that these materials, even if their chemical composition is the same all over the world, they're actually not the same. And so there are great variations in the labor conditions, for example. So these are photos that Holcim, this was really scandalous in Switzerland. Holcim basically paid for an exhibition at one of the major art museums in Switzerland, where they hired a really well-known photographer to travel to all of their production sites worldwide. And they kind of clapped themselves on the back to kind of enter the world of culture. But what it inadvertently shows is also that even under one company producing the same material that's supposed to be the same in all of these places, the protections from the workers are completely different. So in Canada, which is on the far left, the workers are fully clothed in PPE, so they have dust-proof clothing, they have a respirator, helmet, and so on, whereas people working, I believe in Vietnam, on the other end, are not protected from from any of these forces. And so today, through these mechanisms, cement and by proxy concrete is incredibly cheap. A ton of cement costs about 100 euros. And so it's really too cheap. It doesn't reflect the true cost. So it's way beyond this idea of monetary value. And so there is an unevenness actually in this cheapness, this discount, this fact that we don't pay for what it costs to produce it only applies to the global north. It only applies in countries that have already built out their transport and power networks. In developing regions, the price of cement is much higher. So in several sub-Saharan African nations, for example, as Armelle Chaublon has showed in her work, the price of Portland cement is over $450 a ton. So it's 4.5 times higher than it would be here. And to someone constructing their own house with a few small bags of cement, price is not only much higher, it's also less stable. It fluctuates daily on the local market, making it impossible to anticipate the cost of their construction project. And so, in short, those who have the least pay the most, not just in relative, but also in absolute terms. So one last piece. When the Goetheanum was being finished in the 1920s and 1930s, you have to imagine this with me because I don't have an image for it, we see an emergence of a very strong architectural idea of the concept of immutability, that against this 19th century romantic idea of beautiful ruin or decay, that new buildings, modern building materials, so this includes concrete, but also aluminum, chrome, glass, steel. They would be completely resistant to decay. They would remain pristine like their reproductions in photographs. And this was paired with a specific claim that not only would they be immutable, but they would be maintenance free. As long as they were properly constructed, they didn't need maintenance in order to maintain them. And I think this antagonism to maintenance is extremely telling. It goes together with a larger technical shift where the knowledge about construction is being enclosed, that the academy doesn't want to have tacit knowledge competing with its sort of hierarchy as engineering and architecture are trying to establish themselves as professions. But as the Austrian architect Anna Heringer has pointed out, maintenance as cycles of renewal, so thatching, rammed earth, stucco, and so on, becomes a form of knowledge transfer that allows the protection and maintenance of local, non-enclosed tacit knowledge. And so for the technicians, claiming concrete was maintenance-free also meant breaking those cycles and reinforcing the need for formal training, legal prescriptions, and industrialized building. You got that? I know it's a little bit hard without the images. So this inertness goes pretty far, and it works in two ways. On the one hand, it's promoted as something which is modernism, which shines, which is not, again, not decaying. But it is also led to the idea that concrete is particularly associated with death. So it's too inert at the same time. And so we have poor sidewalk frog as an example of that. But also from the 1920s and 1930s onward, and then increasingly in the 1960s and 1970s in alternative health journals, there is a lot of material that shows the way that people were receiving concrete, especially when it was used in residential buildings, was that it was antagonistic to life. So here there's a German article saying basically that you will have no libido if you live in a concrete house. But there were also concerns that it was disrupting the Earth's magnetic field, and so literally draining the life forces of its inhabitants. And we see this also in the stories of the mafia using concrete shoes to dispose of bodies being entombed in dams and so on. These aren't random tales. These are the ways that we as a culture kind of think about a material, and these things are at odds, but the material holds these contradictions. And so this is even stronger today. So anthropologist Penny Harvey, for example, has looked at the concreting done in association with major highway projects in South America, and describes it as the concrete appears as inert matter, unable to summon life and forces because of this fixing power, because of the way that once you cast the concrete, it fixes everything in place. And so things, for example, in this little town square, aren't as flexible anymore. They're not moving around in the same way. And yet, how did we get there? Because we also see so much evidence of concrete not being inert. And so here we return to the Goetheanum, where we see works of repair in place, where we see examples of the concrete surface degrading in places where the concrete has already been patched. And in many cases, different generations of this patching occurring. But there was this belief that concrete was inert was so strong that when evidence of decay began to appear in the 1920s and 1930s, engineers, they didn't want to hear it, and they reacted with shock. And so this was published, for example, in the mid-1930s, showing the effect of acid on concrete. And the accompanying text talks about it's almost impossible to believe that concrete isn't permanent. And even though, again, this is almost laughable today, it's something that has repeated, that each generation of material scientists and engineers believes that the vulnerabilities of the material have disappeared because their new improved concrete is now superior and has overcome these limitations. So here's another example of when these vulnerabilities were appearing. And so despite these repeated claims that new improved concrete could endure, it kept not enduring. It was, of course, more fragile than it was communicated. And so this brings us to, we could talk, for example, about Stephen Jackson's idea of broken world thinking, of that we need to change our perspective and think instead through fragility, to think of infrastructure in today's world as increasingly cracking and breaking down, and thinking of this as a mode of approach in, quote, a world in constant process of fixing and reinvention, reconfiguring and reassembling into new combinations and new possibilities. And so he talks, for example, about the yards where shipbreaking happens, or where boats are broken down. He talks about cell phone repair shops, Wikipedia editors who are constantly making all of these small modifications to the entries. And he sees this as a way of thinking about maintenance and repair as foregrounded, as an aspect of technological work that is a way of talking not just about functional tasks, but also moral relations in the world of technology. And so that's why I think it's so interesting to talk about this, and to talk about this idea of inertness as the sort of story of why we let things crack, the prehistory to what Stephen Jackson is talking about. Because what we are able to trace is that even in historic photos of this building, as you see on the left, just a couple decades after it was finished, we already see the need for patching, sometimes to make changes because something that is so solid is also a liability, but in other times because cracks have spread because there are no expansion joints. And then here on the right-hand side, the same image, but after this practice that I was describing before of béton cosmetic has come in and removed all of these flaws. And so here's the state of one of the facades of the Goetheanum today, where in the 1990s, they replaced all of the concrete. They made a latex mask of the entire facade, removed the outer layer of concrete, and recast a kind of simulacrum with this new concrete. So to turn it around, if this idea of inertness has pushed care aside, what happens if we introduce a more dynamic view when we think about materials? And so this was the subject of an exhibition that I contributed to that was at the Pavillon d'Arsenal earlier this year, where we wanted to look at concrete as this kind of, not just the spectacular buildings in concrete, but all of these exposed concrete buildings that we don't really want to have, but we have them, and we know that if we just discard them and build something new, that we are making the crisis that we are in even worse. And so what we looked at in this contribution was this idea of hubris and broken promises, and then the cycles that appear of patching, repair, new issues, hiding the vulnerabilities that are different from other forms of repair that are so current right now, because when you enact these concrete repair practices, you hide, again, the vulnerabilities of the material. You make it look stronger than it actually is. And so we looked at examples instead of where this vitality, where this change is sort of allowed and accepted, either accidentally or also within the agency of the designer. And so here, for example, in the middle of a rainforest in Texas, a former bomb factory, actually, so much water has fallen down the facade of the concrete that the first few centimeters are completely degraded, and you see even into the deep aggregate of the structure, but you also see layers of moss, of rust, and so on, where the entire surface of the material has completely changed. And there are architects who have embraced this. So in this case, a project by Rudolf Olgiati, who's Valerio Olgiati's father, and I think a much better architect, where he wanted he understood how impossible it was to get this perfect facade of concrete, and he wanted instead to pour the concrete in the most rough way possible, so that over time the roughness and the errors would actually multiply. And so this is a house that he built for his brother in Flims, and not only do you see the roughness of the original cast, the way, for example, that two surfaces are not put together evenly, but also the patching in the middle, where when the surface needs to be repaired to protect the integrity of the structure, it's intentionally done in a way that doesn't match the continuity of the facade. And there are structures as well, for example, Artigas at FAU Sao Paulo, that are basically in a constant state of renovation and repair, where I've never visited without seeing some kind of repair and conservation practices going on. That are really in opposition to this, like, again, idea of the pristine repair view, where you see, here's another example of a facade that has been replaced with a latex simulacrum with a new layer of concrete, and where the only place in the facade where the original concrete is visible is this tiny window to show where the original construction date is shown. And so what we looked at in this exhibition is not just examples of the material changing, but also examples where the material, the most dead of all materials, was still even able to kind of enter into more complex relations, also as a sort of as part of an ecological system, no matter how poor it is. So this, for example, is a completely standard reinforced concrete office building. There's absolutely nothing interesting about it, except that Heinz Isler, a Swiss engineer, moved his studio into this office in the 1970s, and he plugged the drains of the roof so that water would pool on the top of the surface. And his idea with this was actually just that a standing layer of water would not only protect the concrete works well under still water, but also that it would act as a free layer of insulation, that the thickness of the water would protect the interior from really extreme heat swings. But over time, the continuity of this pool of water on the roof naturally seeded an entire biotope. So by the time that they moved out of this in the early 2000s, they were able to find 5-meter high trees growing out of this. And so what you see in the middle of the picture is the thickness of this vegetative layer pulled back to reveal actually that allowing this wildness on the structure has actually protected the concrete better than if one had not allowed this to grow. And so again, there's something in our thinking about the material, thinking that this would be detrimental when actually what it does is protective. And then a final example, which I think is the most beautiful, and I end here, is then where this has really been enacted in the nicest way in the Merritt-Oppenheim Fountain in Bern. Merritt-Oppenheim, a really amazing conceptual artist, where here it's a really simple original design. It's a pillar, a hollow pillar of reinforced concrete with a sort of spiral that water drips down all the way. And the idea was that over time, the water moves slowly. And again, that plants would naturally seed themselves there. And so what you have now is the buildup of this mineral crust from the hard water. So calcium deposits that then build up enough that plants are allowed to, that plants can then anchor themselves in these knotty mineral growths. And so now the surveys show that there are over 40 varieties of plants living on this structure, birds nest on the column, there's algae, and so on. And so there is this possibility, actually, if we look at counterexamples, of thinking about the materiality and the vitality of the material, to think about different relations between the structure and this idea of change. So I'll leave it there. Thanks.
Thank you very much for your lecture. Does anyone have a question?
Hi, thank you very much for your presentation. I had one question regarding maybe the first part of our lecture, which is this construction of an argument to validate or to explain what's concrete. Why were you going to use concrete? And I was wondering, how do you study the creation of an argument? Is it like a historical study? Is it more like an STS study?
It's very boring work. What it is going through years of discourse that unfolded mostly in professional journals, and reading the way that people were thinking about the material. So the way that there was a really, I think actually it's very different from today, that there was a really vibrant technological discourse that crossed architecture, civil engineering, and even mechanical engineering. There were shared technical journals where architects, engineers, and critics published extensively and talked not only about individual projects, but also about their ideas about the material. And so in order to reconstruct this, one of the main sources is really just reading through, kind of from the start at the end of the 19th century, all of these journals, but also the treatises, the student notebooks that record the way that materials and architecture were being taught and how it changes over time. And then the third layer is, of course, what you can read in the iconography of the material, not just the way that it's used in architecture, but also the way that it's represented in drawings and photos and sketches and so on. And also when it's not represented, when it really doesn't matter, actually. And because in many projects, it was just a matter of cost, for example, that something's built out of concrete versus stone. Yeah.
Il y a d'autres questions?
So earlier we wanted you to participate and answer 3 questions, but maybe we'll talk about that a bit later. But one of the main question we discussed beforehand was, could you give us example of a building that is vulnerable. And I think you said something interesting about the fact that it's difficult to represent a building that would be vulnerable. Would you like to develop this a little bit?
Yeah, so I mean, one of the things that I think many people are kind of trying to overcome today is that, I mean, if I understood correctly, the studio is framed also in terms of repair, but through the idea of prostheses and so on. And I think what I try to show today is also that the change doesn't necessarily need to be about adding and removing components of the building, but also thinking about the ways that the materials of the building themselves are also changing. And so I think both of these things need to go together, but the idea of a prosthesis is easy to draw, and therefore it's easy to conceptualize as something, as an architectural gesture. But to think of buildings as things that aren't fixed in place and static, that a building that was built in 1950 today is something completely different, how do you draw that? And so I think one of the barriers that we have to thinking about buildings as things that are changing is actually that we don't know how to draw or to represent easily that change. I think we know how to photograph it, you know, like there's plenty of photos of the patina, for example, of, you know, the way that copper changes, the way that the surface of concrete changes, but to kind of anticipate and document it aside from preservation practices is very difficult. Okay. Yeah. Okay. So there's a question online, any link between Andreas Malm's notion of fossil capital and liquid modernism? And the answer is exactly. I mean, I think they're in a way two sides of the same coin we see as key parts of the Great Acceleration. So to make Portland cement, to sinter limestone at a really high temperature, you need tons of fossil fuel, and it needs to be cheap enough that you can keep the price of cement so low as to use it again without limit. And so one is kind of, the concrete is sort of predicated on exactly on this idea, and both are also parts of planned economies that have been manipulated to keep them much cheaper than the true costs actually are.
Any other question?
No. Okay.
Ouais. Ah, il y a des questions là? Ah.
Thank you for your thank you for your presentation. I'm gonna take the bait that you threw out to us at the beginning of your presentation and ask you about Frankenstein.
Yeah.
Yeah, because you so it has no relation to concrete, I imagine. But you said that it's a feminist novel.
Yeah.
Why is it?
Well, so really this has nothing to do with concrete, and I don't know how much you're actually talking about monsters or like the canon of monsters over the course of the semester, but I mean, I think the more or less the to go back quickly, maybe this idea of I took the quote because I think it explains the way that again that this monstrosity doesn't come without desire, and that we're horrified of concrete because of the promise that it also holds, and that we have to understand this reflexive relationship. But in terms of Frankenstein's monster, the creature as a novel, I think that the interpretation of it is such a great example of the patriarchy, because what has been completely missed is that there is this entire meditation on the horror of producing life. And it's a book that is written by a mother, by a woman whose mother was one of the most famous feminists in history, Mary Wollstonecraft, who died days after giving birth to Mary Shelley. And it's a woman who was of an age where she was trying to have children The children died in infancy. She miscarried. Her friends, her relatives would have been going through the same thing. And there is this, again, there is this reflexive relationship. There is the power of creating life, and there is the horror that creating life also creates death, and that not knowing the line between life and death, as is one of the central questions of the creature, is the creature alive because it's been composed together and electrified, or is it dead because it's not natural, is I think a really key part of the story that remains a kind of minority reading of the book.
Thank you. Maybe just for Frankenstein, it's also about an invention that escapes the control of its
Yes,
inventor.
exactly.
No?
Yeah.
So I think for the concrete comparison, it's quite clear.
Exactly.
And maybe for the feminist part, also that, of course, the story of Mary Shelley is very deep in that one into it, but it's also the impossibility of Frankenstein himself to create a feminine counterpart of his creation. So this is where it basically ends, no?
Yeah. Yeah, and I think that also, again, in a way shows the limits of our thinking, because the question is it really, did it really go out of control? I think is the other key question, or is that what we call externalities, or things that were unforeseen, consequences, are they not actually just part of, actually really ingrained into the system? I think it's not an accident that it's everywhere. It was designed to be that, way.
Thank you so much. It was really, really inspiring and interesting. And I was just wondering about the choice of examples of buildings you reunited here. Because you didn't choose to show contemporary buildings, examples of a concrete. So I was wondering why, and if so, where would they go in your categorization, or would it be another categorization? I don't know.
Well, the simple answer is that this comes out of a historical work, but I think also because if the question is about repair and mutability and so on, to take something which is new, it sort of limits the we can talk about, again, this uncertainty of the mystery of what goes on in the formwork and how it comes out and how we hide the things that goes wrong, but we can't talk about the way that the building has changed over time. And so I guess that would be the reason for looking at it in that way. And then, I mean, I think for as much discourse there is about changing how we do things, my critique would be that for the most part, we engage that by looking at renovation projects, but not by changing the way that we design to anticipate what would come next. And so in a way, we repeat these mistakes of the past because we make the change to something that is old. And so we think we're being radical because we're not just doing new construction, but we don't think about how thinking about who will do, like what happens in the next generation will change what we do now. Oh. Okay. I'll read it so everyone can hear it. It says, can we say that we create monsters by adding little things without looking at the larger picture and the impact of that assembly? For example, de-skilling, use of water, ubiquitous material, and so on. And finally, a monster in one world might become a marvel in another. You can switch worlds by time also on that sentence. And so I think, yes, I think first of all, on the one hand, there is this confluence of forces. There is, for example, there are certain like geological facts, for example, that there are many places in the world where limestone is easily accessible, and that's why we use cement in so many places. But then there's also the sort of agenda of the material industry to sort of make it as easy as possible to use this. But on the other hand, if I understand the second half of the comment, this is maybe another answer to why I look historically, because the building culture that we have today is not the result of our values or ethics today. It's the result, it's slow. Building culture changes very slowly. And so we have things that are locked in place, not just thinking, but also really infrastructures that we fight that are the result of previous modes of thinking that we now have to grapple with. And so that's one of the reasons why I think it's so important when we think about what this transition that we do now needs to be, that we don't think in tabula rasa terms, but we think rather from what we are already grappling with today, which is effectively things, history still having an agency in the present moment.
More question? No. There is a new message.
Okay.
From the monster. Thank you.
Okay.
Okay, so thank you so much for this lecture. And yes, we are very happy to invite you, and it was super interesting. Thank you so much.
Thanks.